All right, let's talk about something that I think drives all of us a little crazy. You've been there, right? You're trying to fix a simple issue and you find yourself trapped in this endless digital loop with a chatbot that just does not get it. It's honestly one of the most common frustrations in our modern lives. But have you ever stopped to wonder why? With all the incredible leaps we've made in AI, why does it still feel like we're speaking a totally different language from our devices?
I mean, you type out a perfectly clear request, and it comes back with something completely out of left field. It asks you to repeat yourself, or, and this is my personal favorite, it offers you a list of options that have absolutely nothing to do with your problem. It is infuriating. But what if I told you the problem isn't just some random glitch? It's actually a really fundamental challenge that goes right to the heart of how AI learns to understand us in the first place.
So just take a look at this sentence. To you or me, this is a totally straightforward, everyday kind of request. It's exactly how a real person would talk. But for a typical conversational AI, this sentence is a complex puzzle that it's almost designed to fail.
So what is it that's so confusing for a chatbot here? Well, that one little request actually has two different goals packed into it. First, you're stating the problem, I forgot my PIN, and second, you're making a request based on that problem. Send me a new debit card. See, most automated systems are built to handle just one thing at a time. So when we talk like actual humans, with multiple connected ideas, they just get stuck.
So, how do these systems even begin to try and figure out what we want? Well, this is where we get into the core technology that powers pretty much every chatbot, voice assistant, and automated service out there. It's all about decoding your intent.
The brain behind this whole operation is something called natural language understanding, or NLU for short. You can think of it as the AI's personal translator for human language. Before the system can do anything, before it can answer you or act or transfer you to a human, the NLU part has to figure out the main goal of what you just said. It's the absolute first, most critical step.
An NLU breaks this puzzle down into two main jobs, kind of like a detective solving a case. First, you've got intent detection. This is the motive. What does the user ultimately want to do? In this case, get a new card. Then you have slot labeling. These are the clues, the essential details like debit card or PIN that you need to actually fulfill the request. When this all works, it feels like magic. But when it fails, it's usually because the AI was built on a really shaky foundation.
And that brings us to the real culprit here. The problem often isn't the AI model itself, but the data it was trained on. To teach an AI how to understand language, you have to feed it millions and millions of examples. But as researchers from the universities of Edinburgh and Cambridge have pointed out, the data we've been using for years has some pretty serious flaws.
In fact, they have identified 4 major hurdles in these existing datasets that are holding our AI back. These hurdles are what prevent it from really grasping the rich, messy complexity of a real human conversation. So let's take a closer look at what they are.
First up is the single intent trap. Most of the training data out there is just way too simple. The AI learns from these neat and tidy sentences like send new card, not our messy, realistic example from before. So it's basically learning an idealized, sterile version of language, not the way we actually talk. Second, we have the single domain bubble. An AI gets trained on a ton of data for one specific topic, let's say banking. But it can't take what it learned about making a payment and apply that logic to a different area, like booking a hotel. This makes the systems really rigid. They can't generalize their knowledge. Now, the third hurdle is a huge one, the English-only bias. The best, most detailed data sets for training these systems are overwhelmingly in English. This creates a massive digital divide, where AI just flat out doesn't work as well for the billions of people around the world who don't speak English as their first language.
And that leads right into the fourth hurdle, a problem researchers have a great name for, post-edit tease. So picture this. You use a machine to translate an English sentence, and then you have a person come in and quickly clean up the grammar. The result is language that's, technically correct, but it sounds really unnatural and clunky. It sounds like it's been edited. Well, AI trained on this post-edit tease is going to struggle to understand the casual, everyday way that real people actually speak.
So, to fight back against these 4 problems, this research team created something new. They built a better training ground for AI. They developed a dataset from scratch that was specifically designed to teach AI how to understand language in all its messy, multi-layered glory. And this table just shows you the difference so clearly. In the middle, you've got your typical dataset, which usually covers just one language and maybe 18 different user goals.
But then look over on the right at Multi-3NLU++. It covers 4+ languages, a whopping 62 different intents, and most importantly, it actually allows for multiple intents in a single sentence. It's a massive leap forward in realism.
So what makes this dataset so different? Well, it directly attacks each one of those 4 hurdles we just talked about. It handles multiple intents and covers different topics. It's truly multilingual, with languages as diverse as Spanish, Marathi, Turkish, and Amharic. And here's the critical part. It was created by professional human translators, not machines, to make sure the language is natural and sounds real, completely avoiding that post-edities trap.
Just look at this. This is our original complex sentence, now expertly translated into Spanish, Turkish, Marathi, and Amharic. This is the kind of high-quality, diverse data that AI needs to learn from. It captures all the different ways people express the same idea across cultures and even across totally different writing systems, like the Devanagari script for Marathi and the Ge'ez script for Amharic.
Now, you would think that training an AI on this fantastic new dataset would basically solve the problem, right? Better data in, better AI out. Well, when the researchers actually ran their tests, they discovered something really surprising. A much deeper challenge was hiding underneath.
Take a look at this chart. It shows how well the AI performed across different languages. And here's the shocker. Even when it was trained on the exact same number of high-quality examples from their new dataset, the AI's accuracy in Spanish, that's the red line, is consistently way, way higher than its accuracy in Amharic, the orange line. So the new dataset helped, but it also exposed this persistent underlying gap.
And here's the key takeaway. The gap isn't just about this specialized training data. It's about the foundational knowledge the AI gets from pre-training. That's when it basically inhales these vast oceans of data from the internet, from books, from articles, before it ever sees a dataset like this one. Languages like English and Spanish are high resource, with trillions of words available for that pre-training. But languages like Amharic are low resource, with just a tiny fraction of that data out there. This gives the AI a massive head start in some languages, creating a performance gap that even a perfect specialized dataset can't close on its own.
And, this isn't just some technical problem for researchers to figure out. This is a real question of global equity. If we aren't careful, we could end up building a future where the most powerful AI tools only really work for a small fraction of the world's population, leaving billions of people behind.
As the researchers themselves put it in their paper, the whole goal is to build systems that are tough enough to handle the incredible diversity of human expression. It's about teaching our technology to adapt to us, not forcing everyone on the planet to adapt to a narrow, English-centric version of technology.
Ultimately, the ambition is actually pretty simple to say, but incredibly hard to achieve. To build AI that can understand a user in Addis Ababa, where they speak Amharic, or in Mumbai, where they speak Marathi, just as fluently and accurately as it understands a user in London. Which leaves us with a final, really provocative question. Creating better datasets is a huge, vital step, but this research proves it's not enough by itself. We also have to figure out how to close this massive resource gap between languages. So what will it truly take for our technology to finally reflect, respect, and understand the full, amazing spectrum of human language and culture?